Kubernetes is amazing at orchestration, but it doesn't natively enforce security best practices. As your Kubernetes adoption grows, you face questions like, how do I prevent developers from using the latest image tag in production? Or how do I ensure that all containers have resource limits defined? Manual enforcement simply doesn't scale. Code reviews catch some issues, but human error is inevitable. You need automation, and that's where Kyverno comes in. You've probably heard the term shift left, but what does it actually mean? Let's use an analogy. Imagine you're building a car. The old school way of doing quality control is to actually wait until the car is fully assembled and then run a bunch of inspections. If you find a problem like a faulty engine part, you have to stop the line, take the car apart, fix it, and put it all back together. It's slow and incredibly expensive. Shifting left is actually moving all of those checks as early as possible in the process. You inspect the engine parts before they go into the engine, you check the chassis before the body is attached, and the whole idea is to catch problems when they are small, cheap, and easy to fix. In the world of software and Kubernetes, it's the exact same principle. For too long, we've relied on finding problems late in the game, during staging tests, or even worse, when a customer reports an outage. Shifting left means we build security and validation right into our development workflow. We want to give developers instant feedback on their manifest files, not a panicked 3 a.m. phone call from the SRE team. The true shift left starts on the developer's machine, long before our code is even deployed. Our first tool for this is the Kyverno command line interface, or the CLI, and this allows us to test our Kubernetes manifest against our policies without needing a cluster at all. Now let's take a look at a common Kubernetes deployment for an Nginx server. In this example, we have a very simple Nginx deployment, and as you can see, we are using the latest image tag. And this actually breaks the promise of predictable infrastructure, because whenever there is a new image released, this deployment is going to pull it, and we don't know what's going to happen with that particular image. In addition to this, we can see that this deployment doesn't have any resource limits or requests, so this means that this deployment can actually take all the CPU and memory from the node. And we can also see that this deployment doesn't have any liveness or readiness probes, so we don't know if this is going to work well or not. So I've defined 3 policies for these. The first one is actually blocking deployments that are trying to use the latest image tag. There is also another one that requires probes, so liveness and readiness probes for all of the deployments. And I also have another one that actually requires resource limits, so it must have limits for memory and CPU. As I mentioned before, you don't have to have everything already deployed in a Kubernetes cluster. What we can do is actually run the Kyverno CLI with these policies against the deployment manifest that we want to use. So let's do that. So I'll just do Kyverno apply, and I'm going to use the policies directory and the Nginx resource. And we can see that we have 3 errors. The images must not use the latest tag, all containers must have readiness and liveness probes, and all containers must have resources limits defined. This is particularly useful, especially if you're trying to find issues when you're developing your Kubernetes manifest, and also if you're using it in a CI system, this can easily block merges to your main branches. Local testing is great for developers, but we also need a safety net for the cluster itself. This is where Kyverno really shines as an admission controller. So now let's install it in our Kubernetes cluster, and I'm going to use Helm for that. So now I'm ready to install Kyverno as a Helm chart, so let's do that. Then we can see that Kyverno was installed successfully, even though we have a couple of warnings. Now I switch to Lens, so we can see here the Helm release was deployed 23 seconds ago. We can go to pods, and let's search for Kyverno related pods. And we can see here that all of them are in a running state. Now I'll just open a terminal and go to the place where I have my code, and I'll apply the Kyverno policies. I've applied them successfully, and now what I'll do is I'll try to apply the Nginx deployment. And we can see we have an error from the server. The admission webhook has denied the request because our Nginx deployment violates our policies, all 3 of them. We can see them right here. And that's exactly what we wanted. And in order to actually make the deployment of the Nginx application, we have to modify the Kubernetes manifest and to add a different image tag, require the health probes, and add the limits per se. So let's do that as well. This is how the manifest looks like after we've added everything. So you can see here that right now I have an image tag, which is not latest. I've added resource limits and requests, and I've also added a liveness probe and readiness probe. So now let's try to apply it again. And as we can see, this was created successfully. So let's search for it and see that it was created a couple of seconds ago. So with Lens, you can also check the CRDs. So to do that, I'll go to definitions and then select the cluster policy from Kyverno.io. And we can see here all the policies that we've deployed. And if we click on either of them, we are going to also see a summary of what events have happened. And we can see this policy has blocked the Nginx app that we tried to deploy initially. Lens also has a built-in AI assistant called Prism that can help you with anything that's happening inside of your Kubernetes clusters, including Kyverno. It can help you with writing policies, but at the same time, it can help you with manifests as well to ensure that they respect the standards you want to apply with your Kyverno policies. So let's get the code that violates our policies and then open Prism AI and say, check all the Kyverno cluster policies and let me know what I need to do in this deployment to ensure that it will pass them. So as you can see, the deployment will be blocked by all three Kyverno policies. It tells us exactly what the policies do, and it also gives us an example of a compliant container spec. By combining Kyverno's native resource model with a powerful UI like Lens, we get a clear visual understanding of our entire policy landscape, making governance and security management dramatically easier. So let's zoom out and look at the big picture. You've just seen how to build a multi-layered automated defense system for your Kubernetes cluster. The first layer is your developer's local machine or your CI pipeline. Using the Kyverno CLI, you catch policy violations before they're even merged, giving you instant feedback at the earliest possible stage. The second layer is your cluster's runtime. The Kyverno admission controller acts as the final unbreakable gatekeeper, ensuring that no misconfigurations ever slip through. And finally, you have a layer of observability. Using a tool like Lens can help you visualize, manage, and audit all your policies and their impact from a user-friendly interface. This isn't just about making your cluster more secure, it's about making it more reliable, predictable, and easier to manage. If you want to dive deeper into practical ways to secure and automate your Kubernetes clusters, do me a favor and hit that subscribe button. That's it for this one. See you the next time.